Hello, everyone. I hope I'm coming through right now. I hope. Are people hearing me right now? I'm looking at the chat right now to see if I'm coming through. Awesome. All right. And I just want to, I'm just doing one last thing here. Oops. Still getting some, still learning this thing here. I'm just going to ask for some quick, just asking for some technical help here. So let's do some psychology. So while I'm waiting on something here, I'm Dr. Mole, Dr. John Mole. I'm a psychology teacher at Cheltenham High School, which is in Wyncote, Pennsylvania, which is in the Philadelphia suburbs. Obviously, I'm here as my role for Fiveable, and I'm doing, obviously, the AP Psych CRAM, and tonight we're doing Unit 1. My doctoral degree is in psychology. I have been very passionate for psychology. I'm not going to go on to I'm not going to go into a long discussion about how I got into psychology, but it's a very big passion of mine. I am obviously a teacher. I'm a researcher. I primarily do research in consciousness and specifically hypnosis. That's my expertise in psychology is in hypnosis. Of course, the powers that be decided to be such a great idea to take hypnosis out of the AP curriculum, so go figure. But it's a very fascinating field. But tonight we're going to be doing Unit 1, and I'm going to get this up and ready here. All right. So I'm going to start sharing my screen here. I think I'm going to do this. I hope I'm doing this right. All right. So let's get this. Let's see here. All right. So we're seeing a share of a Fiveable Google Slides sheet. Yes, no, maybe so. Just making sure. All right, so here we go. Hopefully this is all going to work out here. And I'm going to turn on closed captions. And here we go. All right. So let's get started. First off, the heads up, we are being recorded, and this could appear on our website. So if you have a name that's really funny between you and your friends, that would be very much misunderstood by the general public, I suggest perhaps you change your name so you don't have to worry about that. But at any rate, let us, now that we have that taken care of, bear in mind again, this is the internet, and there is nothing private in the internet. That's a lesson that we all must learn. So anyway, having said that, our social media, Twitter, Facebook, well, not Facebook. I don't think we are on Facebook, but on this, Twitter, Instagram, and YouTube. So those are the little housekeeping things. So let's get started. So Unit 1 deals with the major perspectives, and it also deals with the research components of this. So the major perspectives, if I tell students that if you understand the major perspectives, like you know them through and through, that's at least 10% to 20% of the AP Psych exam. That's not a guarantee. I have no research to back that up. But if you know what a behaviorist is or what a behaviorist does, then when they get to Dr. Jones does behavioral therapy, or Dr. Jones believes that development is based upon a behaviorist perspective, knowing those what the behaviorist perspective is, the behaviorist paradigm, that makes it much easier to answer those questions, so that you don't have to have the abnormal unit perfected or the developmental unit perfected in order to answer those questions, because you know the perspective. So, all right. First, we start off with the historical perspectives here. Structuralism, it's one of the earliest ideas of psychology. The idea was that consciousness is made up of certain parts, much like how the brain is made up of different parts. You have the medulla and the amygdala and the hippocampus and so forth. If the brain is made up of different parts, then so too should consciousness be made up of different parts. And the idea was they would use this thing called introspection. It's a very important thing. Oops, I'm sorry, I skipped here. Just still on structuralism here. They would use this introspection so that if I'm having an experience, if I'm looking at a blue light, let's say, I want to know what things, what physical experiences, what am I experiencing as I see that blue light? There's a pressure on my shoulders. There's a feeling of tingling in my forehead. I'm making this up. Every person's different. But the idea was that structuralism is this idea that consciousness is made up of different parts, and they would use introspection to understand it. Now, the problem with structuralism is that they assume that much like how everyone has the same brain parts, more or less, then so too we should have the same makeup of consciousness, but everyone would have a different introspective report of something. And it was not very reliable. Plus, there was very little applicability, because they said, well, we're not going to apply this until we have the structure figured out. Well, they could never figure out the structure, so very little application never came of it. So the functionalists, on the other hand, there's that word function. Here they're trying to apply, okay, how can we take, and this is really simplifying the idea of the whole functionalist perspective, but here, yes, we don't need to understand all of the aspects of the conscious experience, but how can we apply it? Now, if we find that, for example, yes, you look at a blue light, every person's different, but, and I'm just making this, if we find that people over the age of 60 tend to look at that blue light differently than those, let's say, under the age of 20, like their experiences on whole or on average are different, then maybe that tells us something, and maybe that's useful for something. And so now there's applicability. Maybe that tells us something about the nature of, in this case, older versus younger people. And that led to the development of child psychology and developmental psychology, educational psychology, and other major developments within the psychological field. It should be said that most of the psychology you're dealing with today is functionalist in nature. Structuralism does survive today in terms of the introspective reports, because, you know, even when you do a survey, you're doing a introspection in a way. Like, what's your feeling on this? Well, you kind of have to examine your experience. So, okay. Now let's move into more of the specific types here of psychology. We have cognitive psychology, which deals with the thought process. That word, when you see cognitive, Dr. Jones is a cognitive cognitive psychologist, you should know right there and then that has something to do with thoughts, thinking, memory, problem solving, something to do with the thinking and that big noodle that you have called the brain. Thought processes. Cognitive psychology is all about thought, thinking, problem solving. And sometimes what makes it difficult is that we don't just know the word cognitive. If you know that cognitive means thought, you're good to go. Biological psychology looks at, okay, the brain, chemicals, hormones, basically the whole body, and specifically the nervous system, although it does go on to the endocrine system and other parts of the body as well, and how that how all that interacts. And again, that's the basic idea behind biological psychology. Humanistic psychology looks at the potential of people, the strengths of people. Its emphasis is growth. And by the way, a lot of these perspectives can be narrowed down into buzzwords. So when you look at the humanistic perspective, you're talking about empathy. You're talking about unconditional positive regard, which will be in a different unit. You talk about self-actualization with Abraham Maslow, again, different unit. Those buzzwords, it's about achieving our highest potential. It's about being our best selves in a way. There's a lot of talk about positive psychology today. And positive psychology is an outgrowth of humanistic psychology. There are some who will say, gosh, it's really humanistic psychology rebranded. I'm not saying that. I have heard other people say it, but they're very closely related. Psychoanalytic psychology, here we're talking about subconscious drives. Here we're talking about this Freud guy and this Jung guy and other people as well, who are not all guys, but those are some of the two major people there associated with the psychoanalytic field. But subconscious forces, id, ego, superego, again, things that we'll talk about in a different unit. But again, buzzwords here. Dr. Smith believes that psychological disorders are the result of suppressed, hidden memories of some kind. That right there tells you that it probably has something to do with the psychoanalytic field. Okay, again, buzzwords associated with this. Gestalt psychology is something we see most often in the sensation and perception unit, although technically it's a type of therapy too. I mean, not technically, it is, but doesn't really apply in AP Psych. But Gestalt, basically, when we talk about the Gestalt, the sentence that's often associated with it is the whole is greater than the sum of its parts. Basically, you see a triangle there, but there is no triangle. You don't see there are not three completed sides, but our brain sees a triangle. In fact, there's none there. It deals here with perception, sensation and perception, and how we interpret the world, all the sensory input around us. It's not, and it is its own field. Gestalt psychology has a very rich history, a very fascinating history. So, all right, behavioral psychology, two assumptions about behavioral psychology. Two major assumptions. And if you can get these these two assumptions down, then behavioral psychology becomes so much easier. So, first, everything about you, or nearly everything about you, is a result of your environment. The clothes that you wear, the sports that you do or don't do, where you want to go to college, what you want to do for college, the music you listen to, it's all the result of the environment that's around you. Through conditioning, through punishments and reinforcements, through modeling, through associations, associative learning, all of those things have led you to be who you are. Forget about your genetics, forget about the genes, forget about all of that. It's all about the environment around you. Second, only behaviors are worthy of observation. You cannot observe thought process. Thought is an impure thing to observe. You can't observe my thought process. You can't tell what I'm thinking. You just can't. So instead, what you do is you focus on the behaviors instead, because those are the only things that you can observe. It's not to say that behaviorist denies the existence of thought, but it's not a very important thing to study. It's not, you can quantify behaviors, you can count them, you can operationalize them so easily, but you can't simply do that with thought process. Finally, socioculture, social psychology falls into this in a way, but how our culture, how our environment, when I say environment, not from a behaviors perspective, but the area in which we live, the people, the norms, the customs, the traditions around us, how that affects me as a person, how I'm a member of that group. And that's a very important field, because things that we might consider a disorder, or at the very least out of the ordinary here, might be considered normal, or at least closer to normal, or not as unusual perhaps in a different culture. And that's something that's very, very important. Likewise, we might do things that we consider in the United States here, let's say, as normal, but in other places of the world might be considered out of the ordinary, strange, or eccentric. After all, we let a groundhog tell us when spring begins. So, but needless to say, sociocultural psychology is a very important field. It's gotten much more important over the last 20 years, 20, 30 years, as we take into consideration social cultural perspectives. Evolutionary psychology looks at things we talk about: adaptations, survival of the fittest, which I know is a very overused term sometimes. But the idea is that our behaviors, what we do, how we act, how we make decisions, are the result of our evolution, are the result of natural selection, are the result of us trying to promote. And again, I'm really oversimplifying it here. Promote our evolution to better ourselves in an evolutionary perspective. through natural selection to maximize reproductive success and so forth. Biopsychosocial, here, similar to the biological approach, but also acknowledging that it's not just the biology, that there are also, I mean, yes, I could have a chemical brain imbalance, let's say, that might be responsible for some psychological disorder, but because of the environment in which I've been raised in, maybe it doesn't manifest. Or maybe I do have a psychological disorder that could be diagnosed, but because of my culture, but even though the brain might not show it, like it might, quote unquote, typically show. So that's biopsychosocial. It's a combination of the biology as well as the human interaction around us. Psychology's domains, basically, how is it practiced? How do we practice it here? Clinical psychology and counseling psychology, for our purposes, are, I don't want to say the same because there are subtle differences, but as far as AP psychology is concerned, we really don't go into those differences. But basically, the treatment of a psychological disorder of some kind, and also maybe getting advice, getting guidance. Developmental psychology follows the growth of a person, the growth, the maturation, the physical development, the mental development. I don't want to use the word development because that's parroting, but the mental growth, the emotional growth, different types of growth that can occur, maturation that can occur across the lifespan. Educational psychology looks at, in this case, learning practices. How can people best learn? Psychology has contributed quite a bit to this. Tricks that are very powerful when it comes to learning stuff and remembering stuff. Many teachers have not been taught that, and I, as a teacher, was not taught it myself. Some very important cognitive psychology things that are typically not taught. Educational psychology looks into that. Experimental psychology tests a hypothesis. Not all research is hypothesis testing. Let me be clear about that. But a good deal of quantitative psychological research tests a hypothesis or tries to observe a phenomenon, tries to make inferences, or tries to understand some phenomenon of some kind. Industrial organizational psychology. Industrial and organizational are two separate things, but typically lumped together. And it basically deals with the workplace environment. Hiring the right people, picking the right people for a job, making the workplace environment the most ideal place you want it to be. Because I'm sure some of us have had the experience where we work a terrible job. The job is just terrible. And your boss could double or triple your pay, and yet you'd still be unhappy. How can we boost worker morale so that you are happy and still pay you a good wage, but it's not always about the money. What else can we do to make the workplace environment better? Personality psychology deals with the tendencies of people to act in a certain way, to do certain things that are very persistent. They're characteristics of a person to act and do certain things. And personality psychology looks at those characteristics and what makes them come to be. Positive psychology, I talked about that in the last slide a little bit, kind of a outgrowth of the humanistic psychology movement. And I don't want to define a way where it's almost identical to humanistic psychology, but for our purposes, it kind of works, focusing on the strengths of people, the goodness of people, and working on the improvement of people. Not to say that people who are positive psychologists see clinical or counseling as clinical psychology as wrong. That's not what I'm saying. But whereas clinical psychology, and I'm really oversimplifying it here, whereas clinical psychology might try to, quote unquote, fix what's wrong, positive psychology tries to emphasize what's good about people, the strengths of people. And like I said, and clinical and counseling psychologists will do that too. Let me be very clear about that. Again, we're talking about perhaps too much of an oversimplification, but in terms of understanding it, that's what positive psychology does. Social psychology, how people act and make decisions in groups, how the group affects people's decisions, how it affects how people's decision-making ability, their behaviors. Social psychology can talk a lot about, a lot of the things we're seeing in the news about people, believing that this is true or not believing that something's true. Why is it people hold on to a belief even if they're presented with evidence to the contrary? Social psychology gives ideas behind that. Psychometrics is basically the study of, well, I should say it's the science of designing psychological studies in a way. It's how do I design good surveys? How do I design good questions? How do I design a good experimental setup or a good research design of some kind? It's not so easy. You take those state standardized tests, love them, hate them, whatever, say whatever you want about them. But one thing that's very true about it is that each question, in theory, was looked at, reviewed by several people. Is this question as free as possible from bias? A bias-free question is perhaps impossible, but is it is it understandable given a certain amount of education and so forth? And it's not always so easy. So also the data analysis, what's the best way of analyzing data? Psychometrics are all within that field. All right, so let's delve into some research methods here. A correlational study. When we do a correlational study, we are looking at relationships. We are looking at relationships between basically two variables, although you can do a study in which you're doing multiple correlations and therefore multiple relationships between numerous variables. Technically, you could do a three-dimensional correlational study. There's way, but that's for our purposes well beyond the scope of this course. So with correlational research, it is a relationship between two. Oops, sorry, I'm going to get to the survey in just a second. Relationships between variables, and one thing we have to be wary of, and hopefully, if you are taking an AP Psych course, your teacher has emphasized this in some way, that just because a relationship might exist between two variables, it doesn't mean necessarily that one is causing the other. It's possible, and frankly, to have a causal relationship, a correlation must exist. But if you start with the correlation, you can't conclude without further research, without further study, that one is causing the other. I mean, A could cause B. If A and B are related, A could cause B, but B could be causing A, or perhaps another variable like C is causing A and B, much like how there's the correlation between ice cream sales and drownings, people who drown, or the number of drownings are reported. Obviously, temperature has to do with that, because when it's warmer, more people swim, and unfortunately, there are going to be more people who might drown, and more people are buying ice cream in the warmer weather. So that's an example of that third variable problem. It's sometimes called the third variable problem. It's that idea of a third variable playing a role here. Survey, it's a questionnaire. True, false, agree, disagree. You get people's thoughts on something. Experiment, I apologize for the weirdness of this PowerPoint slide right now. Experiment, you are testing a hypothesis. You are manipulating a variable. You are manipulating a variable. That's the important thing here about experiments. You are manipulating a variable. You are changing a variable. You're changing an independent variable to see if that affects, with an E, I should say, affects with an E, a certain outcome of the dependent variable. That if I change the lighting in my room that I'm in currently, does that affect how well you understand what I'm saying? Okay, that so more on that a little later on. Cross-sectional research, what that does is that is a type of research study in developmental psychology where I am looking at, I'm studying different age groups of different people all at the same time. So I wanted to get people's political opinions. So I'm going to give surveys to 18-year-olds, to 40-year-olds, and to 80-year-olds. And I want to compare the three age groups. And I'm doing that all at once. That's a cross-sectional study. Okay. And if you look at where it says cross-sectional study, the things above that, if that arrow represents a timeline, I'm doing those three age groups all at once. Now, a longitudinal study, on the other hand here, is where I follow the same group of people over an amount of time. So I might start with them as babies, research them in some way, follow up again when they're children, middle-aged, or not middle-aged children, when they're, let's say, in their early adolescence, and then maybe when they're full adults, I'll research them again. And so I check for changes over the time frame. Now, there's advantages and different disadvantages to both, which are going to be covered in a different unit. Naturalistic observation is where I'm going to observe people. Okay, I'm going to see, I'm going to witness, I'm going to collect data, I'm going to measure people in a setting. And it doesn't have to be literally in nature, like out in the open air. It could be in a real life situation. I want to see people's shopping behavior, so I'm going to go to a mall. Maybe not right now, but I'm going to go to a mall and I'm going to, and you might say, what's a mall? Do they still exist? I'm going to go to a mall and I'm going to watch people's shopping behaviors as they go out and buy. Or I'm going to study how children play, so I'm going to go to a school playground and watch the children on the playground. That's naturalistic observation. Case study is where I look at a rare and unusual case. One that is so, I can't research it in any other way. Perhaps you learn about the story of Phineas Gage, who had due to a mining accident, had a pole go through his head. And he lived through it. And we were able to find out how does a pole going through your head affect your behavior, your personality? That's the idea. You can't do an experiment where you take volunteers and you put a pole through their head. You can't do that. But instead, you find unusual cases where this might have happened, and you can study it this way. It's one or maybe just a few rare cases where no other way you could study it. And a big thing that appears on FRQs, a free response question, is your operational definition. And sometimes they use the phrase or the term operationalization. And maybe in the chat, make sure if someone types out operationalization. For our purposes, it's kind of the same thing, although there are some nuanced differences. But operational definition, how am I going to measure it? I'm going to measure happiness. Well, how do I measure happiness? I can't just hold up a ruler to you and measure your happiness. Am I going to measure it based upon how much dopamine is going through your bloodstream right now? Am I going to measure it based upon how many times you smile in an hour? Am I going to give you a survey on a scale of 1 to 10? How happy are you? And all those things are possibilities there. So how am I going to measure? Now, some of those measures are good. Some of those measures might not be as good. But regardless of whether it's a good or valid operational definition, it's still an operational definition. How did I go about measuring it? Although I did talk about the experiment to some degree, I want to kind of delve into the experiment a little bit more and talk about some of the terms here. The experiment is the only type of research for our purposes where you can infer cause and effect. The problem with experimental design is that it can be very complex. So you perhaps learned this in middle school, different types of variables. When it comes to the experiment, your dependent variable and your independent variable. And even in high school and frankly in college and sometimes in research, real life researchers, we sometimes get them mixed up. So the independent research, or excuse me, independent dependent variables, the way I would do this is that the dependent depends on independent. The dependent depends. The dependent variable depends on the independent variable. I think students' test scores or how well they do in the test depends on how hot the room is or the temperature of the room. Right there, you got your dependent variable, the test scores or student performance being dependent, room temperature being independent. So depends on dependent, depends on independent. If you can remember that, it becomes a lot easier to do. Control or controlled variables. These are variables that you're not changing, that you're trying to keep consistent. So if I'm trying to teach different types of teaching methods, let's assume that we're in a normal teaching environment, no such thing as COVID, or COVID's over, we got all the vaccines, and et cetera, et cetera, et cetera. We're back in the classroom. And I want to test two different types of teaching methods, the traditional teaching method, whatever it is, and some new way of teaching. So I'm going to, my independent variable in this case is my the type of teaching method. I have the experimental condition, I have and so forth. But I have control variables. Control variables means everything else will try to be the same. Same type of classroom, same temperature, same teacher perhaps, same school, same environment, whatever. I try to keep as many other things keep it the same so that they don't change all that much, so that the only thing that is affecting the outcome is the independent variable. Can everything be controlled? Of course not, but hopefully it comes close. Extraneous variables are variables that can vary that I can't control. They're kind of the opposite of a control variable, ones that I can't control. Now, one type of extraneous variable is the confounding variable. Confounding variables are ones that can interfere with the influence of an independent variable. So right now I kind of gave you quite a bit of stuff here in the last 30 seconds. That's quite a bit here. So I'm going to back up just a bit. So first off, let's talk about the confounding variable interfering with the independent variable. So I believe room temperature is going to affect how well students do on the test. Okay. Now, could there be confounding variables, ones that could mess it up? Yeah. It just so happens that I give the traditional teaching lesson at 10 a.m. and I give the brand new teaching style at 2 p.m. Now, I think we've all been in school long enough to know, for those of you who attend a traditional school, that how you feel at 10 a.m. versus how you feel at 2 p.m. are two completely different things. And so maybe students are tired. And so maybe they don't do as well in the new teaching method group because, hey, they're just tired because the time of day was a confounding variable. Okay, it's interfering with the influence of the independent variable. Maybe the independent variable is affecting the outcome. It's affecting the dependent variable. But there are other things that might be affecting it too. Now, how is that different from an extraneous variable? Basically, a confounding variable is a type of extraneous variable, but there are extraneous variables that play little to no influence on the independent variable, or that interfere with the influence of the independent variable. Let's say, the local sports team lost the past weekend. The major sports team, they lost their game. I mean, could that somehow affect, is that a variable? Like, can I control, the outcome of the major sports team, the local sports team? Probably not. Or, is that going to affect the outcome of the experiment? Probably not. So it's an extraneous variable that's not confounding in that case, but there are some extraneous variables that can confound. Okay, dependent variable just kind of clarifies a little bit more. You have your independent variable, but you also have confounding variables that can affect the dependent variable. And there are extraneous variables that won't affect the dependent variable, but there are some that will, and that's when they become confounding variables. Okay, groups in an experiment. Pardon me here. So, groups in experiment. We have your control group, which for our purposes gets no special treatment. Again, a person who's a very rigid experimental psychologist might not like that particular definition, but for our purposes, it works. So they get the traditional teaching method. They get they don't get the special thing that we're testing here. In drug studies, it might be the placebo, or they might be the waitlist group where they get nothing at all, or no type of therapy or anything like that. Your experimental group gets the special treatment. They get the actual drug, not just the placebo. They get the actual drug. They get the actual therapy. They get the brand new teaching method. If I think playing music affects student performance, the control group might be no music. The experimental group might be the one that gets the music. I need to use random assignment in an experiment. Random assignment is where a person in an experiment, for our purposes, a person in an experiment has an equal chance of being in either the control group or the experimental group. Notice I'm not using the word random or assignment in my application there, because otherwise I'd be parroting the definition, or parroting the term in the definition or in the application, which can be problematic. Every person has an equal chance of being in the control group or the experimental group. So you're an experiment, you're a subject in my experiment, I flip a coin, control group, experimental group. Now, obviously, I might not actually do it like that because there's experimental bias going on there, but I might use something where every person has an equal chance of being either in the control group or the experimental group. That's not the same as random selection. Okay, random assignment refers to being in the experiment and going into either the control group or the experimental group. You have an equal chance of being in either one. All right. Mean, median, and mode. And I will talk about random selection later on. Mean, median, mode. Okay, measures of central tendency. Your mean is the average value, which is most easily affected by extreme score. So everyone was getting like 78, 79, 80, 81, 82 on that latest psych test. But then little Johnny Mole didn't study for the test. He blew it off. He stayed up and binged on Netflix the night before and, barely was awake through the test and scored a 24. And whoosh, the class average went down. An extreme score sent it way, way down. That outlier, that extreme score being an outlier, is affects most easily the mean. Your median value is the middle value. I put the numbers in order, and on the AP exam, they've done this in the past where they give you a bunch of numbers and they say which one's the median value. Now, so in the chat, let's do this. Put the numbers 4, 7, 2, 0, and 8. Now, in that, if you type them out as that, I believe my middle value there in that list was 2. Like as I said it, like the one that was in the middle. To get the median, you need to rearrange those numbers and put them in numerical order. And then find the actual middle value. And to be honest, I just said those numbers out loud, and for all I know, 2 could be. But basically, that's how you get the median. Okay, make sure you put those numbers in the correct order. Your mode is the most frequent value, the one that appears most often. It's the easiest thing to do. It's like, geez, there seems like there were a lot of 47s on this last test. There's your mode right there, the one that appears most frequently. The mode is the one that could also have more than one. There could be more than one mode. Some psychometricians will talk about there being more than one median. You could have 2 medians. Whereas others say, well, no, you take the average of the 2 medians. But for our purposes, something can be bimodal or multimodal. There's several modes. And if you look at a bell curve, it's the tallest point is your mode. And one that's bimodal would have 2 high points that are of the same height. Might look like a camel's back or something like that. So there can be more than one mode. Okay, so scores on a multiple choice test. And again, this is just how you might do this. To get your mean, you add them all up and divide by the number of scores, and there's your mean. On the AP exam, that I asked you to calculate a mean, they would not give you this many numbers. The numbers would be relatively easy. And typically, ones that perhaps you could eyeball, like they might say, like they might give you a choice of 75.8, and then they might give you like 56 and 95. But again, the numbers they would give you, if they do appear, would be very easy to work with manually. It wouldn't be 15 numbers. It might be at most 5 or 6, I think. So the median is the one that's in the middle here. So because there are 15 values, it happens to be the 8th value. I think I got that right. Yeah, 7 on one side, 7 on the other, and the 8th one being in the middle. So be aware of that. Again, they would give you easy numbers to work with. They wouldn't give you, 35 numbers to work with. They give you one so that, and if it is a lot of numbers, they would probably be in order. They wouldn't give you like 35 numbers out of order, and you would be spending 6 minutes putting them in the correct order. It just wouldn't work that way. Mode is the one that appears most frequently. 81 appears twice. No other one appears more than once, so that's your mode. Measures of spread is measures of variation. When we talk about variation, it means how much spread there is in a data set. If you take a test and everyone got 80, 81, 82, 81, 80, 81, 82, 80, between, there were a lot of scores like very close together. There's very little spread. There's very little variation. But if you had a 100 and then you had a 60 and a 98 and a 42 and a 98 and a 6 and all over the place, more variation, more spread. The range is your highest value minus the lowest value. Easiest way, it's the most primitive way of measuring a measure of spread. Standard deviation is a little bit more complicated. It's a standard measure of variability in which you can compare the variation of one distribution to the variation of another group of people. So Mrs. Smith's class, they took a test and there was a lot of variation, a lot of spread in the scores. Mr. Jones's class, there was very little variation in scores, very little spread. The standard deviation allows you to work that out, to kind of compare that. In terms of how that might apply in the AP exam, that might give you bell curves. The one with a lot of variation, it's a very elongated bell curve. One with very little variation would, be a very skinny bell curve, whereas one with a lot of variation would be spread way out, way out. And so, yeah, but basically when it comes to standard deviation, you are not going to be asked to calculate one by hand. They might give you a series of numbers and say which one is a standard deviation. If they do that, they would do it where it was so blatantly obvious. Let's say the scores on the test were 95, 95, 96, 96, 96, 95, 96, 96, 97, 96, 90. So they're all between 1 or 2 points from each other. So what happens then is like, which one? Well, what's the standard deviation? And they might give you like 10 or 0 or 100, like ones that couldn't be the standard deviation. The fact that, it would be something that's very, very, it would be something that you could eyeball that would require no manual calculations. So this was where I talking about correlational research. I'm revisiting it here. Correlation, how do variable A and variable B relate to each other? When we talk about correlation, how do they relate? Well, when variables go in the same direction, if one variable changes in a certain direction, in a certain way, if the other variable also changes in the same way, in other words, as one variable increases, so too does the other one, or as one variable decreases, so does the other one. It's the same thing, really. That is what they call, that's one way, okay? But it could also be an inverse way, okay? Where if A goes down, B goes up. And if A goes up, B goes down. Again, kind of the same thing. That's an inverse correlation, okay? So there's two possibilities there. Or the third possibility is that there is no relationship. As A changes, there's no discernible pattern between the two. Well, when the two variables change in the same direction, we call that a positive correlation. When there's a positive correlation, it means that the variables are more or less changing in the same direction. As one variable changes in a certain way, whether it goes up or down, the other variable goes in the same direction. It's a positive correlation. Now, if it's an inverse correlation, it's a negative correlation. Sometimes they might use the word inverse, but when it's a negative correlation, it basically means as one variable changes in a certain direction, whether it increases or decreases, the other variable goes in the opposite direction. So as variable A goes up, variable B will go down. As variable B goes up, variable A goes down. I think that's why I said it's the same thing in the end. Now, something you should understand, and if there's no relationship, there's no correlation. Understand that this, when it talks about positive and negative, it simply refers to the direction of the relationship. In other words, as one variable changes, does it go in the same direction or does it go in the opposite direction? When we talk about positive and negative, we talk about the direction of the relationship. Positive and negative in this case do not mean good or bad at all. It has nothing to do with it. There's a positive correlation between tobacco use and lung cancer. That's a positive correlation. How could that be good? It doesn't mean positive. Positive does not mean good. Because you can have positive correlations that are rather bad and you can have negative correlations that are a good thing. So, like the amount of exercise you do and the chance of developing heart disease is a negative correlation, because the more exercise you do, the less chance you're going to have of developing heart disease. That is a negative correlation, and that's pretty good. Obviously, there are positive correlations that are also good, negative correlations that are bad, but the positive name and the negative name in terms of correlation tell you nothing about whether it's a good thing or a bad thing. It just tells you the direction of the relationship. Correlation, again, as I said before, does not infer causation, because, for example, forest fires and ice cream there is a positive correlation there. As one variable goes up, so too does the other. It is possible that the ice cream, we could say, because given that relationship, we could say ice cream sales are caused in the forest fires. People have made sillier connections of other analysis in the past. Like, oh my gosh, people are buying ice cream that's sparking flames all around us. We better ban ice cream sales to save the forest. Sounds silly. A second possibility is equally silly, that the forest fire is causing ice cream sales. Oh my gosh, the coniferous forests are burning down. I feel like Rocky Road right now. That is also silly. The third possibility is that there is some variable, in this case, the climate. When it's hot out, guess what? There's a greater chance of forest fires because the forest is drier and is sparking more easily ignite a fire than in the winter when it's usually more damp. When it's hot outside, more people are going to want to buy ice cream. Okay, it's that third variable problem it's sometimes called. So understand that. Whereas, even though it looks like there's a relationship, in fact, there's not. And then we call that a spurious correlation. It's usually where we observe a relationship where in reality there is no actual relationship. Yes, the data do connect, but it's misleading. It's not really there. Yes, you do the analysis, and as one variable goes up, so too does the other, but there's a third variable causing the two right there. Correlation coefficient. This is here we get into some numbers here. Basically, a correlation can tell you about the direction. And this goes back to this positive and negative correlation. So a correlation coefficient, it's a number and this number tells you something about the correlation. The correlation coefficient, which ranges between -1 and +1, with 0 being in the middle, that number is going to tell you two things. The first thing being the direction. And the fact if it's a positive number or a negative number, that tells you the direction. If it's a positive number, it tells you it goes in an upward trend. As one variable goes up, so too does the other. Likewise, if one variable goes down, so too does the other. They basically tells you the same. They change in the same way. And if it's a negative number, it tells you it's an inverse relationship, whereas one variable goes up, the other one goes, or as one variable changes, the other variable changes in the opposite direction. So that the positive sign or the negative sign simply tells you the direction of the relationship, positive or negative. And then the other thing is the strength of the relationship. How much do those dots, if I were to put all the data into a scatter plot, and I put all the dots, how close to a line do they actually look? And right there, that's going to be a number from 0 to 1. You might say, wait a minute, didn't you say it ranges between -1 and +1? Yes, but for right now, let's just concentrate on the 0 and 1. If it's 0, it tells you that there is no line that you can get from this at all. There is no correlation. There's no relationship. There's no line that you can make. There's no direction you can get from these dots. Whereas 1, it's literally it's a straight line, up or down, up or down. And then the positive or negative tells you which way that line is going, if there is a line, obviously. So looking at this here, okay, here we have a correlation from 0 to 1. When there's 0, there is no correlation. No relationship can be discerned. No line can be seen. Here I have two, the same exact scatter plot here. But if I said, can you make a line of best fit out of this? You would probably struggle in doing that and say, no, I really can't. Okay. Now, what if it's a weak correlation? And there is no rule about what makes a correlation weak versus strong. But let's say it's around 0.2, 0.3. Some would say that's a modest relationship, but for our purposes, let's look at a moderate correlation. Okay. Around 0.5. Now look at the 0.5. Okay, 0.5, you can see it looks like it's getting closer to a line. It looks more like a line than the 0. And the negative 0.5 also looks like a line. The only difference between the two is the direction. The positive tells you it's going upwards because one variable changes in a certain way. The other variable changes in the same direction. Whereas the negative, as one variable changes, the other variable changes in the opposite direction. Okay, so just to give you, a quick example here, because I realize I'm kind of leaving you here with some really good examples here. A positive correlation might be between your shoe size and your height, or a person's shoe size and height. Okay, I mean, clearly, as people are taller, they tend to have bigger feet. Okay, likewise, if they're not as tall, they tend to have smaller feet. A negative correlation, the more TV you watch at home, the less your GPA. So if you keep watching more and more TV at home, guess what? Your GPA is going to go downwards. But if you cut off the Netflix, Amazon Prime binge, okay, suddenly you might find your GPA going up all of a sudden. Okay, inverse relationship. Anyway, the number here, whether it's positive or negative, simply tells you how close to a line it's getting. What if you get a strong correlation here? Look at the 0.9. Now it's getting really, really close, okay, to a straight line. Comparing that 0.5, it's a negative 0.5, it's very, very close. 0.9 and negative 0.9, getting pretty close to that line. Again, the only difference is the direction. And then a perfectly straight line tells you it's a 1 or a negative 1. Now, this is something that some people, this is a trap that sometimes students fall into, and be very careful about this. A correlation of 1.0, is not stronger than a correlation of negative 1.0. In terms of strength of relationship, it's the same exact strength. The sign merely tells you which direction the dots are going. They've asked this very question in the past. Which of the following is the strongest correlation? And they will give you choices like 1.6, which you can't have because it ranges between negative 1 and positive 1. So it can't be beyond that either way. But they'll give you something like 0.6 and negative 0.7 as two of the choices. And then they'll give you like 0.1, negative 0.1 or something like that. The correct answer, the strongest correlation there would be the negative 0.7 is stronger than the 0.6, because again, the signs don't tell you about the value of it. It's not like it goes up from negative to positive, tells you that the relationship is getting stronger. No, the sign merely tells you which direction it goes. After you look at that sign, okay, it tells you what direction it's going. Forget about the sign. Now look at the number, compare the numbers, and you'll see which one is the highest number, whether it's positive or negative. Take the absolute value, if you will, and just work with that number, and whatever is left, whatever is the highest, that's between 0 and 1, is going to be your strongest correlation. Here are some bell curves. I talked about this a little bit earlier, but here's a visual representation of this. As the standard deviation, the measure of spread, goes up, the spread gets wider. It gets wider. It's distributed more. Okay. Actually, let me just go back here just a little bit. Again, as the standard deviation goes up, you might be given on the AP exam which of the following has the largest standard deviation. Well, it's going to be the fattest one, basically. It's not always the shortest necessarily, but it's the one that's going to be kind of wide. Although in the AP exam, they'll make it pretty obvious. Okay, if you understand what a standard deviation is and everything, it's going to be pretty obvious from there. Okay, bimodal, I talked about this. Basically, it's two values that appear the most frequently. It's like a tie for first place. And on a bell curve, it's going to have two bell curves, basically, each being the same height. All right, some ethics in psychology here. I know I'm running a little bit low on time here. Okay, first off, you need to have an IRB approval, institutional review board that reviews the proposed study. Are you following all the rules? Are participants given the opportunity to withdraw from participation anytime they want? Okay, confidentiality, that if you're taking part in a study, that what you say and do is not going to be made public, that it's going to only be looked at by the researchers, that anything that is made public is not going to be brought back to you, that it can't be connected to you, that people won't be able to say, oh, this was John Moll's data. No, that it's going to be kept under wraps, so that your identity is not revealed, that I'm not even going to tell people that you were in my study. Okay. Informed consent means that you are taking part in the study, that you know it's a study, you know data are being collected, you know that a hypothesis is being tested, you know you might be deceived or in some way, there might be some deception, you know that, let's say it's a drug study, there might be some side effects, and that given all that, you are freely participating in the research. You are participating in the research, you're not being forced to do it, that if there's payment, that the payment is not so great that you know, and let's say you're in financial difficulties, that you're doing it just for the money because the money is just that good. You know, if it's a study where it requires a lot of time and effort, then, you know, paying a lot, you know, is justified. But if I'm paying, you know, $5,000 to participate in my 10-question survey, and I go and I find people who are in need of money, like really badly in need of money, an IRB might say, no, that's indirect coercion, because they're not doing it because they want to participate, they're doing it for the money. As a matter of fact, IRBs, for example, homeless populations are considered vulnerable populations, because if I'm giving financial incentive, I'm not doing it, you know, that is a reasonable amount of money, let's say, for the participation. Like a $5 gift card to Starbucks would be a nice thank you for a 20-question survey, but, you know, $10,000 would not. But on the other hand, if it's like something where it requires, like, for example, I'm a participant in the Pfizer study. I was one of the participants who took the vaccine back in the summer. You know, honestly, I think I get paid, it was something like $130 for the visit, to drive up to the place, to, you know, be there for a couple of hours. You know, that's a different story. And plus you know, there's more to it. It has to do with my health. So that's, you know, but if they're paying me like $10 million, that would be, you know, problematic in the eyes of an IRB. Minimize risk, that what we would say here, the potential benefits outweigh the risk. Every study has a risk. If I do a study in which you're going to go up the stairs and go down the stairs, I'm going to measure your heart rate, there's a chance you're going to trip and break your ankle. But every study has a risk. So am I going to do it so that the potential benefits outweigh the risk, that people aren't going to be harmed unnecessarily, and that it's, you know, it does good for science in the end. And that if there are dangers, if there are things, what am I doing to minimize how someone might get hurt in the process? How can I lessen those chances from happening? That if I'm going to use deception where I'm withholding information, I'm withholding the information, that's deception. Because frankly, if I, you know, tell you everything at the beginning, then, you know, if I say, hey, you know, I'm going to teach you with a new teaching method, and you get the brand new teaching method, that's problematic, because now you know now you might act differently. So I might withhold that information, which leads to debriefing. At the end of the study, you know that you are told what the study was all about. You were told about the deceptions and everything else. Okay, that's debriefing. Okay, so that right there is just a brief, you know, like I said, they're all big units, and there's no such thing as an easy AP, and Psych is no exception there. So, but that is just a, you know, brief rundown of the research unit and what goes on. Please check out the fileable forums on Discord. So I'm trying to think of, if I stop this now, I'm gonna go back to the chat here. Okay. Let's see here. So there's the remaining time here of 2 minutes here. So if someone happens to die during a study, they have to stop the study. It depends on the extent of the study. Chances are, in most research, yes. Now, if it's a drug study, they would have, for example, in some of these drugs, these vaccine studies, people have died. Now they have to look at it and say, did they die because of the vaccine, or did they die of natural causes? If a person got the, let's say, Pfizer vaccine and they died in a car accident, chances are that vaccine had nothing to do with it. So deception, when necessary, basically what it means is, if I'm going to withhold information, then I'm doing it because it's necessary for the experiment to work. So that I'm going to withhold some information. Like, you know, there's going to be different groups, and the groups, like, I might tell you I'm going to do something when in fact I'm doing something differently, but I'm not telling you that, because if I did tell you that I'm doing that, then it might ruin the whole experiment. So, The IRB is the Institutional Review Board. It's a group of people, usually, long story short, affiliated with a college or university or wherever the research is being done that is not part of the research team, that basically reviews the research. So I got news for you. Stanford Prison Experiment had an IRB or some form of it. As a matter of fact, Zimbardo said somewhere, I'm pretty sure, he said the one major concern of the IRB was that they didn't have a fire extinguisher in the lab, and so they had to put one in. And guess what? They ended up using it as a weapon. So, all right. So can deception occur? Yes. So there has to be debriefing no matter what. So deception can happen. Deception is possible if it's necessary, if it doesn't cause unneeded harm, and there is debriefing. So, okay. Well, that wasn't the one concern. By the way, I know that there's a lag between what I'm saying and what is on the chat here. So there's more. Obviously, many IRB reviews are going to have more than one concern, but Zimbardo did point that out. But no one pointed out the possibility of happening when it happened in Stanford Prison Experiment. So when would deception be necessary? Deception would be necessary when, like I said, I'll give you a real life example. So if I said, let's say I wanted to, well, okay. Actually, I want to skip units here. So let's say I'm going to teach you with a new teaching method. Okay. I'm going to teach, with some special teaching method, but in fact, I've actually am pumping out music with subliminal messages, and I want to see if the subliminal messages are affecting how you learn. Okay, and in fact, it has nothing to do with what I'm teaching, just the subliminal messages. If I tell you that, well, that could ruin the study. So I might withhold that information. So, I know, Lena, you're going to be doing the answer some of the questions there. I know I answered some of them. Hopefully, I know that bimodal, it's not as complicated perhaps as I might have originally said it, but basically when it's bimodal, it means that there are two of the most frequent values. There's a tie for first place. So that's what we mean by that. So with that, that's my presentation for this evening. I know that Fireable has other resources. This CRAM season, it's the first CRAM for AP Psych, and I'm still getting used to getting familiar with everything that's going on in terms of what is being presented here, or I should say how it's set up. So with that, I'm going to stop the lesson now. I know you'll be on the doing some of the questions still. I thank you for that. And RTA is awesome, by the way. I'm sure you figured that out very quickly. But if I could give a huge round of applause, there we go. But yeah, you do an amazing job. So thank you very much for your time and attention. And I will see you. Well, I'll see your names in the chat with these smiley faces, I guess. Next Monday, I believe, is the next time we'll be doing Unit 2. Take care, everyone.